Math 3, Unit 10, Section B or Section 2. Today we're talking about angles in standard position. This is kind of like the foundation of this unit. We're going to be talking about the unit circle, but you need to understand everything today. So as I'm going through things, if you're ever unsure, like why is it that number, please stop and ask me, okay? So standard position, an angle is in standard position if the vertex is located at the origin. So remember your origin is right there at 0, 0. And one ray is on the positive side of the x-axis, and the ray on the x-axis is called the initial side, and the other ray is called the terminal side. Okay? Positive angles are generated by counterclockwise rotations from your initial ray to the terminal ray. So this is a positive angle. When you're moving to the left, that is going to be your positive angles. If you're moving to the right or going clockwise from here, that's going to be negative. And if you think about it, this on the top of the graph, it's like your positive values. On the bottom of the coordinate plane, it's your negative values. Okay? Also today, as a little refresher, you need to remember your quadrants. So they go in order, starting here in the upper right quadrant. It's 1, 2, 3, and then 4. Okay? Another thing we're going to be working with today are reference angles. So it says, associated with every angle drawn in standard position, except for quadrant angles, there is another angle called the reference angle. The reference angle is the acute angle formed by the terminal side of the given angle and the x-axis. Reference angles may appear in all 4 quadrants, and angles in quadrant 1 are their own reference angles. So if an angle ends up in quadrant 1, it's always the angle going to the x-axis from a terminal side. And so the only quadrant there where the angle, it ends up in quadrant 1, so the angle and the reference angle end up being the same. Okay? See on this one how the angle that they're making is 120 degrees. But if you take this terminal side to the x-axis, this angle is 60.
So it's the part that's like there but not really there?
Sometimes. So like this one, it's both of them. Like they're both the same.
Oh.
Okay, does that make sense? And so you're always going from the x-axis to the ending side. So that's the reference angle here. See on this one, so this one is 240 degrees as it goes around. Well, the reference angle, it always goes to the x-axis from the terminal side. So see how the reference angle and the angle of the actual, that they actually told you to find, they're both part of each other. See how this went 240 degrees to here, but it's always wherever this ends, it's going up to the x-axis.
So it's where whichever one's closest to the x-axis. Mm-hmm. So like it wouldn't go, like for that third box, it wouldn't go all the way around to the other x-side?
Right. And so same with this one, so it went all the way around here. Well, this will end up being your reference angle right here. Okay, and then this reference angle was the same angle as the angle stated. So again, it says remember, and you might want to like highlight or do something to come back to this later. But the reference angle is measured from your terminal side, so the terminal side of the angle that they set, to the x-axis, not the y-axis. Okay? Also, reference angles are always positive. Okay, so for these next problems we're going to practice, there's 2 things they want us, or actually they want us to sketch the angle, and then we're going to identify the quadrant in which the terminating ray lies, and also determine the reference angle. So let's go back up here to this little grid, and we just want to talk about it a little bit. So we know starting right here, this is at 0 degrees, correct? And then going up right here, this is how much? 90 degrees, right? And then when you have a whole angle that goes and makes that straight line, that's how much? 180 degrees. And then this down here is, no, 270 degrees. And then going back up to 0, you would start going around again. And so if you make the whole circle all the way around, this also is how much? 360. And then it would keep going up. Like you would add another 90 and you could find out how much this one is as well. Does that make sense? Okay. So we might have to end up figuring that out later. So example 1, where is 170 degrees? And when I say where is something, I'm asking you what quadrant is it in? Very good. And so we're going to draw the angle by just, you kind of make your little, well, first of all, I guess you could do your line where you think the 170 would be. So it's kind of close to 180. And yeah, they don't have to be perfect. And we're going to end up labeling them. And so what you would do is from your 0 degrees, you just kind of draw a curve with an arrow going to that line you drew. And then we would label that as 170 degrees. Okay, and so you already told me which quadrant it was in, so we're just going to put Q2. However you want to label that, that's fine. You just need to make sure you understand that you're saying it's quadrant 2. Okay, and then I'm going to do R for reference angle. And my reference angle, so we take the terminal side and we draw that down to the x-axis. So we're going to draw a line here. How much would this part be from the ending side to the x-axis?
10 degrees.
And how did you find that?
180 minus 170.
Yeah, so this is going to the 180 mark, right? And so we found that. I'm just going to write this out in case you forget. You can look back. We did 180 minus 170, and we got 10 degrees. So my reference angle is 10 degrees. Okay, so let's try the next one. Example 2. Where is that reference angle going to be? Or, I'm sorry, where is that terminating side? Good, quadrant 3. And so, again, it doesn't have to be perfect, but you know which quadrant it's in. We're going to draw our circle around to that terminating side and label it as 200 degrees, 210 degrees. And then we're going to draw our reference angle, and again, it always goes up to the x-axis. So we already stated that we're in quadrant 3. We need to find our reference angle. And so on this one, how would you find the reference angle? Good, I like that. And so Noah said he's kind of going to go backwards. So he's going to take 210 and just subtract out the 180. And so when you take 210 and subtract out 180, what are you left with?
30 degrees.
30 degrees. So my reference angle is 30 degrees.
Can you also do just the 270 minus 210? Wait, no, okay. Yeah, why would you do 180?
So do you guys agree that this line right here, this is 180, right?
Yeah.
So we're just trying to find out, well, how much does it go past 180? And so if you go 210 minus 180, you find that. So sometimes we're going 180 minus the angle. Sometimes we're doing, you know, the angle minus 180. I don't know, back and forth, just depending on where it lands. Okay? So it's like I'm just subtracting this piece out because I only want that little piece for my reference angle.
Subtract from the x-axis.
Yes, so it's always going to the x-axis, so you always kind of look at your position and decide, am I going to, which way am I going to subtract, basically. Okay.
Whichever, sorry.
No, yeah.
Whichever line it's closest to, like if it's closer to 180, then you would subtract like from 180. Like since the 210 is closer to 180 than 270, you would just.
Well, it's not going to end up going to 270 because remember 270 is your y-axis. It's always going to end up going to your x-axis. So it's either your x-axis, your points are 0 and 360 and 180, and then you could figure out what another 180 is. So you're always going to be adding or subtracting from those numbers. So either from 360, from 0, or from 180 or whatever the next one is, depending if you loop around so many times. Okay, does that kind of make sense? So it's always going to be with this line is where you're going to be subtracting. So this next one's going to be even a little different. Where would 320 degrees end up? Good, quadrant 4. So again, I'm just going to draw my angle. I know it's in quadrant 4. I don't have to be exact, okay? And so our little arrow goes all the way around. We label that as 320 degrees. You guys already told me that this is in quadrant 4, which was correct. We need to find our reference angle. Now, on this reference angle, again, we're going up to the x-axis. Where am I going to draw my line?
From that line to the 360.
Good, from that line to the 360 mark, correct? And so what am I going to subtract from this time?
360 minus 320.
Right, so 360 minus 320, and I get 40. So my reference angle is 40 degrees. Does that make it more clear? Yeah? Okay, where would 70 be? Quadrant 1. And remember, this is the only one where the angle, and we are going to label, sorry, we'll still do an arrow, and that's 70. And the angle and the reference angle are the same, okay? And so, again, this was in quadrant 1, and then our reference angle, we don't have to do anything with it or subtract, we know it's 70.
Is that because it's close to the 0 mark?
Yeah, because that's exactly where you would draw your line.
Quadrant 1.
Yes, quadrant 1 and 70 degrees. Okay. So example 5, notice this one says negative 70 degrees. So where are we going to go for negative 70 degrees? Which quadrant?
4.
Good, quadrant 4. So this one goes down here. And since we're going negative, our arrow is going down. And that's going to be at negative 70 degrees. We already stated what our quadrant was, which was 4. What would be the reference angle on this one? Where would I go to for this reference angle? So we're always going to the x-axis, right?
Yeah.
So we're just going to draw it up. Correct? Reference angles, though, are always positive. And so this reference angle will be what? 70.
Why did you put the arrow like in the quadrant 4 and not?
Because it's negative. So I'm going the opposite direction.
Oh, so you placed the arrow in the opposite.
Yeah, so we're going down 70, so I'm doing my arrow going down the 70 degrees. Okay? Otherwise, if it went around the other way, I'd be making that positive 290. Okay. So negative 100 degrees, which quadrant will that go to?
3.
Very good. So quadrant 3 is correct. And again, we're making the arrow going down or clockwise. And so we're going to label that as negative 100 degrees. You already told me that it's in quadrant 3. Now we need to find our reference angle. Very good. And so it goes up to the x-axis there. And Carson just stated that it is 80 degrees, which is correct. And so see how we're at the 180 mark? If you didn't know, you would just go 180, and on going this direction, I'd have to subtract the 100 from it and find that my reference angle is 80 degrees. Okay, the next one is 620. So all this means is that you're going to like loop around until you get to the spot that you need to be at. How could you figure out what spot you need to be at?
Like draw a different color.
Like, do you know what quadrant you should end in with the 620?
3.
How did you know that?
Because I would I'm going 0, 90, 180, 270, 360, 450, 540, 630, and then back 10.
Nice. Okay, so Noah went through and just added 90 each time. Okay, when I did this is what I did. I went, okay, 620, I know it's going to loop around, it's at least 360, right? So I just subtracted 360 from 620, and I found that that was 260 left. So that's what I did, but you know, not as creative. So 260 is which quadrant again? 3. And so I drew that, but when I'm drawing my angle, it has to loop all the way around and then it comes back to there. Super fun. And how would I label that? Would I label that as 260 degrees? No. Very good. 620 degrees. Okay, and you guys already told me that this was quadrant 3. Now our reference angle, again, the reference angle always goes up to the x-axis. Very good. So we draw that reference angle. And what numbers am I going to subtract for this to figure that out?
620 by 540.
You could do 620 by 540. Me, I like to do it more simple. So does anybody know another way of doing it?
260 minus 180.
Yeah, that's exactly what I did. Now again, you don't have to do it my way, but I'm like, I already knew that this was at the 260 mark. And so I took 260 and I subtracted 180. And when I did that, what did I get? 80, which is what everybody, you got the same answer too. So my reference angle is 80 degrees. Okay, thank you. All right, last one. So negative 300. So we're going clockwise, and what quadrant will negative 300 end up in? Very good, quadrant 1. And so we're going clockwise with my arrow. That makes negative 300 degrees. Quadrant 1 is correct. And then what will be my reference angle? 60 is correct. So we bring that down. It always goes to the x-axis. Mathematically, you would go 360 minus 300 because that's where I'm at, is like the 360 mark. And I would get 60 degrees for that reference angle. Okay. Are we good with this part? All right. So let's go ahead and go to the back side. So we're going to be going through, we're going to ultimately, and we're going to build more on this tomorrow, but we're going to figure out the unit circle and a whole bunch of markings in the unit circle, but this is just going to help us with it. It says find the missing coordinates for the point on this unit circle, and next find the simplified sine, cosine, and tangent ratios for the angle by using this reference angle right here. Okay, so first of all, this is saying that this is your x value. Do you guys agree with that? Okay, so if that is your x value, what is it telling you in terms of the triangle and the circle?
It's the just like width.
Very good. So it's saying that basically from here to here, right? That is negative 4/5. Is everybody okay with that? Because this was my x value. So what it really means at this point right here is negative 4/5. Now, since this has a 5, and we know this is a 90-degree angle, we want to end up finding this missing side. And we know that we can find a missing side by using which theorem? Pythagorean theorem. Okay, but what we want to do is make them so that they all have the same denominators. So instead of writing this as a 1, I'm going to change that to 5/5. Okay, now from there, we really are just going to be looking at our top numbers. Okay, and when you're using Pythagorean theorem, you're not going to use a negative value, although when we square it, it's going to take the negative away anyways. But so to find this missing side, we're going to use our Pythagorean theorem. And we know that is a squared plus b squared equals c squared. And what is the value for c? 5. So I'm going to write a squared plus 4 squared equals 5 squared. And you could have done the opposite there. Remember, a and b, it doesn't matter. Now we have a squared plus 16 equals 25. Subtract 16 to both sides. A squared equals 9, which means that a equals what? 3. So what would I write for that length on that side? Very good. 3/5. Now, would it be positive 3/5 or negative 3/5?
Positive.
And how do you know that it's positive?
It's above the x-axis.
Very good. So just like how this was negative 4/5, it went to the left, that's negative values. So remember on your coordinate plane, this is positive, going left is negative, going up is positive, going down is negative. So we knew that was a positive 3/5, which is how this was a negative 4/5. So what is missing? What's the missing point then here? 3/5. So there were 2 questions. A was to be find the missing coordinate. So I'm just going to write A. The answer is 3/5. Now B, it says find the simplified sine, cosine, and tangent ratios for the angle using your reference angle. Okay, so we're using this angle right here, and I'm going to write this as my sine of theta, and we also are going to find cosine theta and tangent of theta. That little symbol is called theta, just so you guys know. Okay, sorry. Okay, so if you're if we're looking here at this angle, what is the opposite value? So we're looking at this angle right here, okay? Opposite from it is what? Good. And when we're looking at these though, because all of them have the denominator of 5, we are actually only going to look at the top number. Like we can basically take off the denominators. So we're going to be only looking at 3, oops, that was not good, and 4 and 5. And actually when I said 4, I meant to say negative 4. Okay, so opposite from this angle is 3, and the hypotenuse is 5. Cosine, and I should have written this for sine too. This was opposite over hypotenuse, right? What is cosine?
Adjacent over hypotenuse.
Good, adjacent over hypotenuse. So from that angle, what is adjacent?
-4.
Good, -4 over my hypotenuse, which is 5. And then tangent is?
Opposite over adjacent.
Good, opposite over adjacent. And so that fraction will be
3 over -4.
3 over -4. And that's it. Okay, do you have questions on that? Okay. So again, notice on these, we're dealing with the reference angles. Okay? So it's going up to the x-axis. Okay? Now this one could be, they could both be the same. It depends on which direction the angle is going. Okay, so this -5 over 13. Where is that on the triangle?
The side that's going down.
The side that's going down. You're vertical. Vertical, right?
Yeah.
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 Okay, so this right here is -5 over 13. What do I want to change 1 to?
13.
Very good. Why did you change it to 13 over 13?
That's 1 over 13.
Very good. It's the same as 1, and then this way we can not deal with fractions when we're trying to find the missing side. We can just deal with the numerators, the numbers on top. And so how would I set up Pythagorean theorem here in order to find my missing side?
13 squared. Squared.
Close. What is my hypotenuse?
13.
The hypotenuse is 13. So that means that represents which side?
Oh yeah.
The C, correct? Okay. So, and again, we're only looking at these numbers. So again, how am I going to set this up?
A squared plus 5 squared equals 13.
Very good. A squared plus 5 squared equals 13 squared. So we'll go through and solve. A squared plus 25 equals 169. Then we would subtract 25 to both sides. A squared equals 144. And so that means that A equals what? Very good. And so, but specifically, what will be that length?
12 over 13.
And is it going to be positive or negative? And how do you know it's positive?
It's going in the positive direction.
Good. It's going to the right. It's going the positive direction. Okay? Just like this one was going down, which is why it was given a negative value. And so the missing value here is very good, positive 12 over 13. So my answer for A is positive 12 over 13. Then B, we're going to find our sine, cosine, and tangent of theta. Okay, so again, we're only looking at the numerators. So it's okay. So sine, what would be the sine values? Or value?
Negative 5 over 13.
Perfect. Negative 5 over 13 is correct. If I could reduce these fractions, I would. Okay, cosine is what?
Is 12 over 13.
Perfect, 12 over 13. And tangent? Very good. Negative 5 over 12. Questions? Okay. So, this next part says, fill in the missing sides for the special right triangles found below. Then find the acute angle theta that satisfies the following equations. Okay. So first of all, remember the triangles that we figured out yesterday with the numbers? How we ended up changing it from letters to all of them having numbers. Do you guys remember that? It was over here. We remember how we went through and found the sine of 30 and we reduced it and we found that the sine of 30 was a half and all that kind of stuff. Do you guys remember that? And then we realized like, oh, well, you could put all of this onto these triangles and a 30, 60, 90 triangle is 1, 2, root 3 instead of A, 2A, A root 3. Okay? And so on here, if this angle right here is 30, what's that missing angle? 60. Okay? And so going across from the 30, which number goes there? 1. Okay? Across from your 60 is root 3, and across from your 90 is your 2. If you forget which number goes with which, okay, in terms of numbers, 1 is the smallest number there. Root 3, if you were to plug root 3 into your calculator, and I'm just going to show you here real quick. Oops. Okay, so here's square root of 3 in my calculator. When I press enter, see how it's 1.73. Okay, so that is smaller than 2. And so in terms of angles, it goes 30, 60, and then 90. And so the same thing in terms of numbers. Smallest number is 1. The next smallest number would be root 3, and the largest number is 2. So they go proportionally, basically, with the different angles. Does that kind of make sense? Also, remember how we talked about with the 45, 45, 90? That 45 and 45 are both the same, which is why their sides are the same. Okay, so over here, this is 60, which means this is 30. So in terms of writing your numbers, again, always across from the 30 goes the smallest number, which would be what? 1. And across from the 60 will be root 3, and across from the 90 will be 2. Okay, over here, we're missing the 45 degrees. And each of the 45-degree sides are what? 1s. And then the hypotenuse is root 2. Okay, so what they're actually wanting you to do here is find out which one of these matches with which degree. Okay, so basically, we're trying to find what is theta. So they're saying sine of what equals 1/2. So we know sine is what? It's so, thank you. Opposite over hypotenuse, that's what I was looking for. And so if you go through and look there, which one gives you 1/2 for the opposite and hypotenuse? Which degree? 30. So if you're at 30 degrees, opposite is 1 and hypotenuse is 2. So that means this missing the theta is 30 degrees. And however you want to write that, but that is the answer we are looking for, is 30 degrees. Okay, cosine we know is what? Adjacent over hypotenuse. And so we're trying to find something that has root 2 over 2. Now, this side has a 2, but there's no root 2 in it. Do you guys agree with that? This one has a root 2, but there's no 2 in it. So you have to pay attention to what number's under the root. That's going to tell you the type of triangle you're going to go to. So because of the root 2, I'm going to go to the 45, 45, 90 triangle. Now, what do you normally do when you have a root in the denominator?
Oh, you have to bring it.
You end up having to bring it to the top, right? And so if I had, I'm just going to kind of do a little separate thing over here. If I had a root 2 in the denominator, I'd end up multiplying right by root 2 to the top and the bottom. And you see how that ends up becoming a 2, and then the top would be a root 2 if there was a 1 there. So that means that the actual original function, when you have a root in the top here, it really was this, was the original. Does that make sense? So 1 over root 2 is how this should have been. And so which angle gives me 1 over root 2? 45 degrees is correct. So if you're looking at like your 45 degree, adjacent is 1 over root 2. Okay, and it could have been either 45 degrees. So that missing angle is 45 degrees. Okay, now this one doesn't have it as a fraction. Okay, and so we know that tangent is what? Opposite over adjacent. And so they're saying root 3, and if there isn't a denominator, we can always put it over what? 1. Is there any way of getting root 3 and 1 in the same triangle?
Yeah.
Yes. Okay, so we don't have to worry about changing anything here, correct? And usually the ones that you change, just so you know, it's where you have a root and then the same number. See how this one doesn't have the same number on the bottom? So I'm not going to have to change this one, but this one I had to. That's normally if they both match, okay? So what is the tangent? What's going to be the degree?
60.
Good, 60 is correct. So we're going like which side was opposite from root 3? Or which angle was opposite from root 3? Which was the 60, and then adjacent is 1. So the root 3 over 1 works. Okay, so on example 14, do you see how it's similar to example 12? And so what would this one be as the original before you got rid of the root 3 in the denominator? Good, so I'm going to change that to be 1 over root 3. Okay, and then we know that tangent is opposite over adjacent. Okay, and so we're looking for 1 over root 3 with opposite over adjacent. And which angle would that be to? Good, 30 is correct. And so we're looking, so if you go, because you know it's going to be the one with root 3, if I go to 1 And I just need to figure out, well, what's opposite from 1? 30 degrees is. Okay, so 1 is opposite from 30, and root 3 is adjacent, so it works. So you're just kind of working backwards, and then you can go forwards to see if it actually works out correctly. Okay, questions there? All right, example 15 and 16. Okay, example 15, it says, find sine A, cosine A, and tangent A given this isosceles triangle. What is an isosceles triangle?
Two sides of the same.
Very good, 2 sides are the same. And so what we're going to do with this isosceles triangle, because in order to find sine, cosine, and tangent, you need a 90-degree triangle. Okay? And so if I were to bisect this side, draw a line down, that makes that a perpendicular line, 90 degrees. What's going to happen to the length of this base?
It's gonna
Cut in half. So that means this is going to be what?
15,
15 and 15, correct. And I'm just going to mark it on one side. So if I know that this is 17 and this is 15 and I have a 90-degree angle, could I find the missing side?
Yeah.
Yes. What will I use to find the missing side? Very good, Pythagorean theorem. So how will I set up Pythagorean theorem for this problem?
15 squared plus b squared equals 17 squared.
Perfect. Okay, 15 squared is 225 plus b squared equals, and 17 squared is 289. We subtract 225 from both sides. This cancels. B squared equals 64. And when we take the square root, b equals 8. So that means this side right here is 8. They asked me to find 3 things there, and that was the sine of A, cosine of A, and tangent of A. Okay, so that means we're looking at angle A. So what is the sine of angle A?
8 over 17.
8 over 17. Opposite over hypotenuse. What's the cosine of A?
15 over 17.
Good, 15 over 17. And the tangent of A?
8 over 15.
Good, 8 over 15. And that's it. And if you could reduce any of those fractions, you would, but they don't. Okay, last one, example 16, tangent of B. So here is B. They're telling you on this one that the tangent of B is 12 over 5. So from this angle, where do I put the 12? Which side?
You put it on
Opposite
the
side.
The opposite, good, the opposite side, which is AC, good. So that's 12, and then 5 would be
BC.
BC. Could I find my missing length? Yes, how will I set this one up?
5 squared plus 12 squared equals c squared.
Good, 5 squared plus 12 squared equals c squared is correct. 5 squared is 25, plus 12 squared is 144, equals c squared. We add those together, we get 169 equals c squared. And when you take the square root, c equals 13. So my missing hypotenuse is 13. Again, they asked me to find sine A, cosine A, and tangent A. So, oops. Sine A, cosine A, tangent A. So now I'm going to actually looking at my A angle. And so what is the fraction for my A angle? Good, 5 over 13. Cosine is 12 over 13, and tangent is 5 over 12. Any questions?